Hello everyone, myself Simran from Team CloudML. Welcome to the YouTube channel of CloudML. Today, I will be guiding you all through an interview question asked by Tiger Analytics. As you all can see, the question is given on the screen. Write a Python program to find missing numbers from a list. This list is a sequence of sorted numbers. So let's look at an example. This is the input list like 1, 2, 3, 4, 6, 7 and 10. As you all can see, the numbers are sorted in increasing order. And the output is 5, 8 and 9 because 5, 8 and 9 are missing from this list of numbers. So let's see how to solve this problem. For this question, we will be looking at 3 different approaches with different time complexities and we will select the best optimal solution for this problem. So first let's look at the first solution. We will be creating a function missing numbers 1. This is the first function that we will be looking into. It will accept a list which is none other than the list of numbers, and we will be using the concept of list comprehension to solve this problem in the first method. So what list comprehension does is it shortens the procedure to form a list. So what we're going to do is x for x in range LST 0. This LST 0 is nothing but the first element of the list up till LST minus 1 plus 1. This list LST minus 1 is the last element, but why plus 1? Because we know that range function does not include the last number that we have mentioned. It is not inclusive of the last number. But in our case, we also want the last number in the range. Like if we consider this example, we want the range from 1 to 10. And in this case, 10 should also be included in the range. So for this reason, we add plus 1 in the range. If x not in LST. So what this will do is, it will return only those elements which are not present in LST, but which are present in this range. Okay, so now let's apply this function. First, create a list. Let's consider the list as 6, 7, 10, 11 and 13. And apply this function. Give the list as the parameter. Now let's run this code. As you can see, 8, 9 and 12 are printed, which are the missing numbers from this list. So we have used list comprehension, which will first iterate through the range of the given list, and it will check if each element is present in the list, in the original list or not. If it is not present, then it will update that element in the list and return that list. So the time complexity that this function will use is O n raised to 2 n square, because it is iterating through the list 2 times. So the time complexity is O n raised to 2. And complexity is O n square. Okay. So now let's look at the second approach in solving this problem. We will be defining another function, missing numbers 2, and this function will accept the list and the length of the list, which is n. Once a function is created, it will create a list of zeros which will be equal to the last element of the list, or the last element plus 1 of the list. N minus 1, this is the last element plus 1. Okay, so for I in range n, what this will do is iterate through the length of the list and this code will assign the number 1 in all the places where the list value of the ith element is present. Next, for I in range, this line or this iteration will iterate through all the numbers in the list present plus 1. Plus 1 because we want the last element inclusive. And it will check if all the elements in the B list are 1 or not, and if it is 0 and not 1, then we will print the I. Print I. So the function has been defined. Let's apply this function. Before that, create a list 6, 7, 10, 11, and 13. And n is the length of the list. Apply the function missing numbers 2 and pass the given list and the length. Okay, run this code. There's some syntax error, 1 extra bracket. As you can see, we have 8, 9, and 12. Now let's understand the logic behind this code step by step. Okay, so copy this list. This is the list that we have. And first line after the definition, a list having the 0 elements is formed of the length list n minus 1 plus 1. So what is list n minus 1? In this case, this is the list, okay, as you all know. This is LST, and n, your n is the length, which is 5, okay, 1, 2, 3, 4, and 5. What n list n minus 1 plus 1 means? Substituted list n minus 1 means 5 minus 1, which is 4, plus 1. Okay, and list, the fourth element of the list is 13, nothing but 13, which is the last element, plus 1, which is 14. Okay, so it will form an array of zeros, a list of zeros having the length 14. So B equal to like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So this is a zeros list having the length 14. Okay, we have come up till this step. Next is, it will iterate through the range n. Okay, range n means I will begin from 0 and n is 5, so it will end at 5. Okay, it will have 0, 1, 2, 3, and 4. What it will do is, it will substitute 1 at the ith place in the list. Okay, so let's look into it step by step. Consider I as 0 first. Okay, I as 0 first. And what it is doing is, this is the code. Okay, it is substituting 1 at the place. Substitute I in this place, LST 0. I is 0 over here, equal to 1. Here LST of 0 is nothing but 6 is equals to 1. So this B list will get updated. It will get updated such that the sixth element is replaced by 1. So here the sixth element is 1, 2, 3, 4, 5, 6. Okay, wait, 0, 1, 2, 3, 4, 5 and 6. So this will get replaced by 1. Okay. Until it gets replaced by 1, the iteration will increase. I will become 0. Okay, I will become 1. Sorry. I equal to 1 and B of so B of LST, here I is 1 equal to LST of 1 is nothing but 7. The position 7 of B element of the B list will be replaced by 1. Okay, so updated 7th position will be replaced by 1. Next, the I will be incremented to 2, B LST of 2, which is nothing but B our list is 10. Okay, so it will become 10. B of 10 will be replaced by 1. So again, the 10th position, this was the 7th, 8th, 9th and 10th is replaced by 1. Similarly, it will take place for I is equals to 3 and I is equals to 4. B LST of 3 equals to B, it is 11. We have 10, 11, 13. So 11 equal to 1. This is the 11th position and B LST of 13 is also replaced by 1, which means this is the 13th element, the last element. Okay, so this is replaced by 1. This is the final B list that we have got. Okay, and next we have completed up till this step. Now next, for I in range LST 0 and LST n minus 1 plus 1. This LST n minus 1 plus 1 is the last element plus 1. So it is nothing doing, but it is just iterating to the list. What it will do is, now the pointer will increase. Now I is ranging from 6 to 13. Okay, which means I is 6, 7, 8, 9, 10, 11, 12, 13 and 14. Why 14? Because we want this 13 inclusive. For that we have added plus 1. Now if B of I is equals to 0, now it will check if the bth position of this I is equal to 0. So let's check. First this I will be 6. So it will check the 6th position from this B. the sixth position is not equal to 0. Okay, so it will not perform any action. Next, it will be I. Next, I will be 7. Seventh position is also not equal to 0. Next, 8. But 8th position is equal to 0. So what it will do, it will print this 8. Similarly, for 9, ninth position here is the ninth position here is equal to 0. So it will print 9 as well. For 10, it is not equal to 0. 11, not equal to 0. But 12, it is equal to 0. So it will also print 12. Okay, so I hope you have understood the logic of this function as well. The time complexity of this function is equal to OM. Here M is the maximum element of this list, because as you can see, it creates a list B which is equal to the maximum length. Okay, M is maximum number in the list. So after this approach, we will be looking at another similar approach. Okay, so let's see. Here we'll define another function, missing numbers 3. Okay, this will also accept the list and the length of the list. First, it will set a counter to 0. So for I in range, it will iterate through the first element of the list up till the last element of the list, which is n minus 1 plus 1. This is the last element of the list. After iterating, if it will check whether the cth or the counter position of the list is equal to I or not. So this is the counter position of the list. It's equal to I or not. And if it is equal to I, it will increment the counter by 1. Or if it is not equal, then it will print this I. And I. Okay, the function has been defined. Now let's apply this function. First, create a list. We'll use the similar list that we have used previously so that we can compare the results properly. Here n is length of the list. And apply this function, print missing numbers 3. We are not required of print because it is already printing the result. And we need to pass the list and the length of the list. So run this. Here there's an error. It is not I, it would be C, Cth position. So you've got the result as 8, 9 and 12. Let's look at the execution of this function. So this is the list that we have considered, and n equal to 5, which is the length of the list. Okay, so first what this function does is it will select a counter which is c equal to 0. Okay, and then it will start an iteration from list 0 to lst n minus 1 plus 1. Here I equal to lst 0, which is nothing but 6, comma, n minus 1 plus 1 is 14. Okay, so once this is done, here, which means 6, it will be 7, 8, 9, 10, 11, 12 and 13. So first let's consider I equal to 6. Next, what it will do is it will check whether the cth position of LST is equal to I. So here LST, cth position of LST equal to I or not. So in our case, cth position of LST is nothing but the sixth position or the 0th position where C is equal to 0. So 0th position of LST is equal to I or not. 0th position in our case is 6 itself, which is the first position. Okay, so here 6 and I is also 6. So yes, 0th position of I is same as I in our case in the I is equals to 6 iteration. So here, which means that this condition has been satisfied. Okay, so next, what this will do is it will now increment the counter of C and it will be set to 1. Next, I will be 7. Okay, because it will increase, it will increment to 7. Then it will check list of 7 is equal to I or not. Your list of 7 is nothing. LST of 1. It will check the LST of first position because now C is 1 is equal to I or not. LST of 1 is nothing but 7 and I is also equal to 7. So yes, this condition has also been satisfied. Okay. So now C will be equal to 2 and I will be 8. LST of second position we will be checking now, but in our case LST of second position is 10, which is not equal to I because I in our case is 8. So we will be looking at the else block and it will print I. Your I is 8, so it will print 8. Print 8. Now C will be 3. C will be 3 and I will be 8. I will be 9. Similarly, it will check the LST Cth position. Your Cth is 3, C is 3 and LST of 3 is nothing but 11. And 11 is not equal to I, which is 9. So it will print 9. Okay, so this was the procedure of how this code has been done. I hope you've understood the procedure and the time complexity of this code is nothing but O. So the time complexity is ON, which is a linear time complexity because only one iteration has been carried out in this list. As you can see, only one iteration is present in this code. For this reason, the time complexity is ON. Okay, so by all the analysis, we select the last code as the optimal solution because it has a linear time complexity as compared to other programs which have OM time complexity and also O raised to n square time complexity. So the last solution that we have seen is the optimal solution for this problem. I hope you've understood this problem. Cloudy ML also provides various courses to learners who want to transition their career into data science. We have many courses in Python and data science, which are hands-on assignments wherein you can learn easily by practicing. We have real-world problems based on projects with 6-hour Skype support mentorship. Okay, so you can avail these courses on our website, which we have various courses like in data science, Python, SQL, machine learning, statistics, etc., which will help you prepare for your placements and also for career transition. These are the recent success story of our various learners. So do check out the website for various amazing courses. Thank you.